Start talking about functions, we're talking about relations. A relations is a set of ordered pairs. It can be a list of ordered pairs. It can be defined as an equation, such as y equals 2x plus 3. A function is a rule that assigns one element in each set to a unique element in a second set. It is a special type of relation. A function is can be a set of ordered pairs in which no two ordered pairs have the same first coordinate and different second coordinate. For each first coordinate, there can only be one second coordinate. We also talk about, with relations and functions, talk about domain and a range. In a relation, a set of all values of the independent variable x is the domain. So the x's are the domain. A set of all values of the dependent variable y is the range. Let's practice that. Give the domain and range of each of these. Okay. And tell whether it's a function of domain. The x values here would be -4, -1, 1, and 3, the x values. The range, the y values, -2, 0, 2, and 5. Is it a function or not? Well, for each x value, there's only one y value. So yes, this is a function. Here we give the domain and range again. For each, the domain values would be the x values, -3, 0, 3, and 5. And the range is the y values. Well, the y values here are all 5. Is this a function or not? Yes, it is, because each x value has only one y value. It doesn't matter if the y values are all the same. Each x has only one y. The domain and range tell whether it has its function. Well, the domain of this is actually all real numbers, so it goes from -infinity to infinity. We can use interval notation. The range, notice the arrows at both ends, is also all real numbers. For each x there's only one y, so yes, this is a function. The domain and range here and tell whether it defines a function. Now, notice the arrows at each end, and those will go on forever. So the domain is, again, all real numbers. The range, now the range is the y values, and these arrows go on. Those y values are going to go down to infinity forever. So starting with a small number first always, -infinity, and where does it stop? It goes only up to 4, and 4 is included, so that would have a bracket. Is this a function? Well, yes. For each x value, there's only one y value. So yes, this is a function. Now, we're going to agree for domain, unless they tell us otherwise. The domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable. All real numbers that will produce real numbers. No imaginary y's. A handy thing to checking if we have graphs is the vertical line test. If each vertical line represented by a graph intersects the graph at most one point, then the graph is that of a function. Let's take a look at some of those. This function is these 4 points. And you can see we've drawn a vertical line through that one, through that one. Here we'll finish them and get the vertical lines through here. Each vertical line only intersects one point, so this is a... Now we have an oval here and an ellipse. And when we draw the vertical line there, intersects in 2 points. So this is not a function. and you can see the vertical line intersects at only one point. And if I were able to slide this vertical line all the way along my blue function, we would find out that it would only intersect in one point. So this is a function. This shape is what we call a parabola. And again, if we could slide this vertical line along all the way, it would only intersect in one point. So this is also a function. I'll remind you, the graphs that are not represent functions are still relations. So all equations and graphs represent relations. All relations have a domain and range. Special types of them are functions. Now determine this that defines a function and give the domain and range. Oh, y equals 2x minus 5. Isn't this the equation of a line in slope-intercept form? Well, the equation of a line, except for a vertical line, is a function. And the domain would be all real numbers from negative infinity to infinity. The range would also be all real numbers from negative infinity to infinity. Shape, well, if we think about putting some values in, if I put in 3 or negative 3, if I put in plus or minus 3, those two different x values, that would give me the same y value. Would be 9 plus 3 would be 12. If I put in plus or minus 2, I'd get 4 plus 3 or 7. Plus or minus 1, I would get 1 plus 3 or 4. 0, I would get 0 plus 3 or 3. And whatever values I used, it's going to be bigger than 3. So yes, this is a function. The domain is all real numbers. The range, 3 is the smallest I can get. So the range is from 3 with a bracket to positive infinity. Now, just to say whether this defines a function or not. Well, let's think about. Let's say x was, well, wait a minute. X is an absolute value. So x has to be greater than or equal to 0 because it's an absolute value. Now y could be positive or negative because negative 10 would have an absolute value of 10. So if x was 10, y could either be 10 or negative 10. Not a function. The domain, well, x has to be greater than or equal to 0. So from 0 to infinity. The range, though, whatever I put in here, was always going to turn out to be positive. So the range is all real numbers.